Hello, dear students. How are you? Hope that you are fine. I am also fine. Today, online class. Welcome, everybody. Dear students, I am Banik, Assistant Professor, Department of Statistics, Milestone College. Dear students, previous class I discussed the creative question from the chapter 5, Poisson distribution, statistics second paper. Dear students, today I will discuss another creative question from the chapter. Let's start our class. At first I will write the creative question, then I solve the question. Let's see. Dear students, on the average 1 in 400 items is defective. CQ number 3. On the average 1 in 400 item is defective. The items are packed in boxes. Okay, of 100. And I said told that the probability of no defective bulb items is greater than more than 3 defective item. This is the stem from this CQ defective items. At first question, what is the probability function of Poisson distribution? What is the probability function of Poisson distribution? Answer is Px equal to let x be a Poisson variate with parameter m. m. So px equal to e to the power minus m, m to the power x by x factorial, where x equal to 0, 1, 2, dot, dot, infinity. Okay, dear students, you can write in this way. You will get number 1. Second question. Now I will erase the question stem. Second question, question number B. What is the relation between binomial distribution and Poisson distribution? What is the relation between binomial distribution and Poisson distribution? Poisson distribution. You know the question. Answer is Poisson distribution limiting from a binomial distribution. Poisson distribution is Poisson distribution we know that limiting form of Poisson distribution, binomial distribution, distribution. Okay, you have to know that, dear students, in the number of trials, n is very large. In the number of trials n is very large. Number 1, numbering করতে পারো, very large. That means n tends to infinity. Number 2, probability of success is very small. Probability of success is very small. That means p tends to 0. Okay, and n p is equal to m. Number 3, n p equal to m parameter. In these 3 cases, Poisson distribution tends to the binomial distribution tends to the Poisson distribution. Okay, dear students. Now question number 3. We can solve. At first we can write, see, given the probability of defective items, the probability of LITY, probability of defective items. Defective items P equal to 1 by 400. That means 0.0025. The number of the items in the box. The number of the items in the box. N equal to 100. Now we can solve the parameter is, so parameter M equal to NP. That means 100 into 0.0025. That's equal to NP (0.25). We know that N is very large. That means n tends to here n is greater than. Since we can write, since n is greater than 30 and P less than P equal to 0.0025 less than 0.1. So we can use the Poisson distribution to solve the given. So we can use the Poisson distribution. So we can use the Poisson distribution. Okay. Now the probability function of Poisson distribution is, we know Px equal to e to the power minus m to the power x by x factorial. X equal to 0, 1, infinity. Putting the value in this equation, we can write e to the power minus 0.25 into 0.25 to the power x by x factorial. Okay, dear students, this form is called probability function of Poisson distribution. Now we can calculate the probability of the less than 2 defective bulb. Probability of less than 2 defective bulb. So probability of less than 2 defective bulb. Less than 2 defective bulb. Defective items equal to e to the power minus 0.25, 0.25 power 2 divided by 2 factorial. That is, this result is 0. We can write probability of x less than 2. That means probability of x equal to 0 plus probability of x equal to 1. That is e to the power minus 0.25 into 0.25 power 0 by 0 factorial plus e to the minus 0.25 into 0.25 to the power 1 by 1 factorial. The result is 0.7788 plus 0.1947, that's equal to 0.979735. This is the probability of the less than 2 defective bulb. Okay, dear students, hope that you have understand this math. Next, question number D. Question number D. Do you agree with the comments of Mrs. Raisa? Comment your necessary calculation. D question. Do you agree the comments of Miss Raisa comment on your necessary calculation. Okay, solve. From equation 1 we get probability of no defective items. Probability of, from equation 1, equation C. From C we get probability of x equal to 0 equal to 0.7788. We can solve the previous question. Now, probability of more than 3 defective items. Probability of more than 3 defective items. Equal to probability of x less than 3. We can x greater than 3. Thus we can write 1 minus probability of x equal to 0 minus probability of x equal to 1 minus probability of x equal to 2 and probability of x equal to 3 minus probability of x equal to 3. We can write 1 minus 0.7788 minus e to the power minus 0.25. One is 0.1947, 0.1947, probability of x equal to 1, 0.1947, 0.1947 minus e to the power minus 0.25 into 0.25 to the power 2 by 2 factorial minus e to the power minus 0.25 into 0.25 to the power 3 by 3 factorial. We can write 1 minus 0.7788 minus 0.1947 minus the calculating value of 0.0243 minus 0.0020. The final result is 0.002. 0.002. 0002. From the above calculation, we see that from the above calculation, we see that from the above calculation, we see that probability of no defective bulb, probability of no defective bulb, right, or items and probability of more than 3 defective items so that we can write in the probability of x equal to 0 is greater than probability of x greater than 3. Hence, Rice's comment is correct. Hence, Rice's comment is correct. Okay, dear students, hope that you have understand this creative question. You will solve sincerely, and this creative question is your SW. You solve this question and give my inbox. Dear students, hope that you will understand the creative question. If you face any problem, you watch the video again and again. Dear students, no more today. Thanks to all.